All right, we are back for the daily Leetcode challenge 498, lower number, diagonal traverse. So it's one line. Usually that means it's gonna be pretty simple, or at least the wording is gonna be pretty simple. Given an n by n matrix, return an array of all the elements in the array of the diagonal order. Got it. Okay. So you go up, down, up, down, up. Interesting. So is there a pattern? What's the pattern? It's like, huh? You start at 0, 0, then go to 1. Let's just write it out. Kind of what. Let's see if we can figure out some sort of pattern to this. Um, Start at 0, 0, then you go to 1, 0, and then you go to 0, 1. Okay. Then you would start at 2, 0, go to 1, 1, and then go to 0, 2. Okay, I think I see the pattern here. We'll do another example, but you do go to 3, 0. You drop this by 1, upgrade this. Then you would do, well, this is if you're increasing it. But I guess, yeah. If you hit the midpoint, you want to start decreasing it. That's going to be a little interesting, but we'll get back to that. So you go to 3, 0, then go to 2, 1, then 1, 2, and 0, 3. Now, if you're trying to go backwards, let's say this is like what would 3 be? It would be like the len of the box. Remember that it's n by n. It's a little confused. It's not. It could be m and n. That's something we have to think about. But let's just imagine it's ebb by ebb. Um. Hmm. What you want to do is think about this for a second. Instead of starting at you would kind of want to do you almost want to like restart to some extent. You want to restart like 1 len of m. Wait, this is a bad example because that doesn't make any sense. Okay. We'd want to do 1, 2 here. And drop this to 0. You'd want to do this 2. And here you want to do 2, 2. So essentially this axis stays constant while this one increases. and then they flip. This is kind of just a pattern. Yeah, I think this is just gonna be kind of like an interesting one. How many rows are there? One, two, three, four, five. One, two, three, four, five. Is it? How did we know how many rows there are? One, two, three, four, five. It's kind of like, okay. It's the len of, what is it? How do I do that? Like flip the lines. I forget how to do that. Is it shift option downwards? No, that makes a new one. It's option down. Okay. Um, for I in range. Start with the N. We'll do these values first. Boom, boom, and boom. So for the first ones, we will. Oh, gotta remember we have to do. Has to be 1, then 2, 4, then 7, 5, 3. Yeah. We can flip them later. I think that's not a big issue. But what we could do is, yeah, I think what I'm thinking about doing here is just going down. If I is odd, and then we'll reverse it. Okay. So essentially, we'll start at 0, 0, which would be I will be the x-axis, and then it's just kind of gonna be like you got to think about it, kind of. While we're actually gonna set an x here, which is gonna be I, and y is always gonna be 0 because we always start at the top here, and then while x is greater than 0. And then from here, we'll just do or I'm making a separate array because I want to reverse it if I don't think that's gonna be a problem. I reversed it. And then we could do res equals res plus compare. And then we have to update these values. And essentially what we're doing here is we'll be adding to y and then subtracting from x. And that's going to get us this, this, and this. 0, 1, 2. Yeah, perfect. So let's just, I think the best way to do this is to, well, actually, wait, this, yeah, I like this. Okay. I don't know if to put this in a list or not, we'll say. let's return some random value, and then let's print out res. Let's see what we're getting here, just to make sure we're getting the right value on the right track. Yeah, we need to do a list. As I suspected. We got 2, 3, 5. Oh, we gotta do greater than equal to there. That's why. 1, 4, 2. Wait, do we have it backwards here? If it's odd, we should. If it's even, we should flip it. Got it. So we got 1, 2, 4, 7, 5, 3. Okay. Now we have to just do something pretty similar, but for the downward case. So now we're going to do m. We're going to do m minus 1 because we're not going to include the middle. We're only going to have 2. X is going to be set to. Actually, we're going to start it at 1. Yeah. Instead of minusing m by 1, because we'll start here. And then y will be set to the. Y will be set to m. Or x. Or, yeah. It always will be set to the edge. Minus 1. And then we just go back. And again, if it's odd, we are good. If it's even, we flip. While x is greater than 0, that should stay like that, I believe. We add to y and minus from x. Oh, wait, no, this should be while. Y is less than the len of. Essentially, that we'll hit the bounds of the bottom first before we hit the x values. Yeah, looks good. Looks good. Looks good. Yeah, I'm gonna return res here. We're missing a 6. Why are we missing a 6? Wait. No, no, no. I should be y. X should be m. Minus 1. We always start at the edge of the x value. We start at I for the. Yeah. Perfect. Kind of just like you gotta work through this problem. Kind of think about it. Whoops. Okay. Well, we're failing some base cases here. Ah, I see. Oops. I don't know what I'm doing here with this layout. Oh gosh. Layouts. Oh god. Okay. I think we're just missing the base case here. Because what's happening here is we're not. Whoops, wait, we're not trying to look at solutions here. Submissions. The problem is that honestly, if the len equals 1, I'm just gonna you just return itself, right? Yeah. If m or n equals 1, return that. Just return itself, I'm pretty sure. Uh, yeah. Hmm. I don't love that. Wait, what? How is that wrong? Wait. At the left, n equals 1. This is still going to be wrong, yeah. And then mat at 0, right? Well, we have to worry about if n equals m equals 1. Which, we're getting a runtime error here now. Oh my gosh, this is so annoying. Oh, these are like edge cases I hate. What is it supposed to be? And why is this so messed up? Oh gosh. Default. If m equals 1. You just want to return them concatenated together, essentially. Um, which I don't really know how to do. I'm just cheating here. I know these are not the best. This is not like the best way to do this, but not the worst way either. But I wish I could handle these base cases a little bit better. I think I have to add this here. I'm thinking about if this only is square. I think I'm not considering this case. Let's use just this case here. How is that even possible? While x is greater than or equal to 0 and y is less than n. What? How is that even wrong? How is this ever? N is the len of matrix. Oh, wait. Wait a minute, this is wrong. X equals I. Should be M here. And this should be N. Right? Yeah. That's a little dumb by me right there. Now for this example, we are doing 5, 8, and then we do... Oh, I see. It's not always... It's not always... It's where we currently are. Um, it's got to be M plus I because you would count 1, 2, 3, then this would be like the fourth. Or it would be M plus the 1th. Yeah, so it would be M plus I here actually. Wow. Always these little edge cases here that get you. Is it M plus I? Well, it's M plus I minus 1 plus I. Oh my gosh. Because, yeah. Because we're indexing by 0. There we go. So, a little challenging. Yeah, overall, just small errors we just messed up on, but overall, we got the solution pretty well. Um, let's see what they do here. Yeah, I mean, this is worse. I don't even want to read through that. Yeah, complexity is O of n times m because we process each element once. I would make the caveat that it would be technically O of n like 2 times it because every other 2, it'd be like 1.5 n times m because you do for half of them. We're doing like the reverse, which is a little expensive, but other than that, pretty nice solution. Acceptance rate pretty high as well. Uh, yeah, that's it for that one. Thanks everybody.